The motivation behind this work came from a desire to investigate and contribute to the tasks of automated music generation and augmentation. The idea being that music creators often want to include a range of instruments in their works, but do not always have the necessary ability to play or create each of these instruments to a decent standard. We believe that this is where computational methods can assist. We focus our efforts in the rhythm domain, working specifically with percussive symbolic music. Current state of the art in these types of tasks is often achieved with sequence-to-sequence models. A recent addition to this family is the transformer, which has achieved impressive results in NLP and symbolic music modeling tasks over the last few years. We attempt to build on these recent efforts by applying this model to the task of automated symbolic rhythm generation. Our work attempts two tasks, the first of which is generation from scratch, in which our learnt model is asked to produce a new sequence with no user input. The second is continuation, in which a user-specified sequence is passed to the model and the model is asked to continue it. Our process is fueled by the Groove MIDI Dataset, a symbolic corpus of human-performed professional drumming. We subject this corpus to a tokenization procedure, converting our data into a one-dimensional sequence of tokens, each representing a unique pitch, velocity, or silence. We train a Transformer XL model on this sequence, optimized to predict the next token in the sequence. For our generation task, we sample from our learnt model's internal distribution over all tokens, feed this sample back into the model to update its internal memory, and repeat until a specified generation length. Continuation is almost the same, except that we prime the model with our user-specified sequence, updating the internal memory with this before any sampling is done. The authors evaluate the output subjectively, commenting on a range of generations and continuations across various genres and parameterizations. We also subject our results to a series of blind listening tests in which listeners are asked to distinguish between a model-generated sample and one performed by a human drummer. Let's listen to an example generation from the model. The output is symbolic and has been converted to audio by the authors. And here we have an example continuation. This is the user-specified input to the model. And this is the continuation provided by the model. Our model is able to achieve aesthetically pleasing output over long time periods in both generation and continuation tasks. Listeners were unable to reliably distinguish between human-performed drumming and model output in blind listening tests. However, not all generations are of high musical quality, and although the continuations generally are, they exhibit very little improvisation or deviation from the user-specified input. Resource intensity of the process means we are far from creating something that is possible to deploy to a real-time application or something that a musician could use in situ. Thanks.